Hello everyone, I am Shivani and welcome to Civil Series. So this is the next video from the short notes of surveying. So here in this video the topic is leveling. So leveling is used to find out the elevation of given points with respect to the given or assumed datum. Okay, leveling is nothing but finding the elevation, finding the elevation of given points with respect to given or assumed datum This is nothing but a leveling. In case of leveling, two surveys are done. First one is plane survey, second is geodetic survey. Plane survey is considered when the area is less than 250 meters square, and geodetic survey is considered when the area is more than 250 meters square. In case of plane survey, the plumb lines are parallel. This is the surface and these are the plumb lines on this surface. Okay. In case of geodetic survey, plumb lines intersect at the center of earth. Plumb lines intersect at center of earth. Okay, so these are the plumb line in case of geodetic survey. This is the geodetic survey. The next, there are some important terms related to leveling. In that, first one is, okay, before discussing the terms, first we know what the mean sea level. So this is the mean sea level. Mean sea level is nothing but the average height of sea at all stages. Okay, average height of sea at all stages, and datum is nothing but any surface used to find out the elevation. There's nothing but a datum. Datum is any surface used to find out the elevation. Then next, elevation is vertical distance which is above. Okay, this is datum, which is above or below the datum is nothing but elevation. Then last term is benchmark. So benchmark is permanent, fixed or permanent reference point, is nothing but a benchmark to start the survey. So this is the mean sea level, and these are the plumb lines which intersect to the center of earth. These are the normal plumb line, and this is the perpendicular plumb line for this particular figure. If the plumb line is perpendicular, this is also known as vertical line or plumb line. This is also plumb line. These are the three plumb lines here. Then next, any surface parallel to mean sea level is nothing but a level surface. Any surface which is parallel to mean sea level is nothing but a level surface. So this is the level surface. And any line which is parallel to or normal to the level surface or normal to the plumb line is nothing but a level line. So this is level line. Then plane tangential to the level surface. Plane tangential to the level surface is the horizontal plane. Okay, plane which is tangential to the level surface is nothing but a horizontal plane. And any line which is drawn on this vertical or the horizontal plane is nothing but a horizontal line. So this line which is normal to the plumb line but drawn on the horizontal plane, this line is a horizontal line. So these are the few important terms related to leveling. Then next is method of leveling. Here the leveling is differentiated into two parts. First one is indirect leveling. So in case of indirect leveling, three levelings are done. So in that three leveling, first one is barometric leveling. Barometric leveling. So in case of barometric leveling, the difference in elevation, okay, here I represent in a formula. Okay, this is not in a formula, this is in a theoretical form, but for easiness here I represent this barometric leveling into the formula. Okay, so difference in the elevation between 2 points. Here I consider first elevation is E1, second elevation is E2. So difference in the elevation between the 2 points is proportional to difference in the atmospheric pressure, which is P1 for first and P2 for the second elevation. Okay, so difference in the elevation between the 2 points is proportional to the difference in the atmospheric pressure. This is the barometric leveling. Then second one, hypsometric leveling. Hypsometric leveling. Okay, so hypsometric leveling is nothing but difference in boiling point. Difference in a boiling point, which is T1 for first and T2 for second. Difference in the boiling point is proportional to the difference in the elevation. Difference in the elevation. This is nothing but a hypsometric leveling. Then third one, trigonometric leveling. Trigonometric leveling. So trigonometric leveling is nothing but, here in case of trigonometric leveling, the elevation of points are determined by, here consider E1 as a elevation. Elevation of a point are determined by the help of vertical angles and horizontal distance. Okay, here we take the vertical angle and horizontal distance ratio to calculate the elevation of points. This is nothing but a trigonometric leveling in a simplest form. Okay, then these are the three levelings done under the indirect leveling. Then next is direct leveling. Then next is direct leveling. So under the direct leveling, there are four levelings. In that, first one is differential leveling. Differential leveling. So differential leveling is difference in the elevation of 2 points. Difference in the elevation of 2 points. Difference in the elevation of 2 points. Then next is profile leveling. Then next is profile leveling. Next is profile leveling. So profile leveling is nothing but a longitudinal leveling. This is also known as longitudinal leveling, and in this the profile leveling is used to determine the elevation of points at measured interval along a given line. Elevation of points at major intervals. Okay, so here first interval, second, third, fourth, measured interval along the line. Okay, along the line. This is nothing but a profile leveling. And third is cross sectioning. Cross sectioning. So in case of cross sectioning, the levels on each side of main line are at right angles to that line. Levels on each side of a main line, at right angle to that line. This is nothing but a cross sectioning. Then next fourth is reciprocal leveling. Reciprocal leveling. Reciprocal leveling. In this reciprocal leveling, the instrument is set at the center to eliminate the collimation error. To eliminate collimation error. Okay, so here the difference in the elevation between the 2 points is accurately determined by two sets reciprocal observations. When it is not possible to set the level between 2 points, when it is not possible to set the level between 2 points, then two sets of the reciprocal observations are determined, and from that two sets of reciprocal observations we determine the difference in the elevation. Okay, so here this is the formula to use the true difference in case of reciprocal leveling, which is H is equals to A1 minus B1 plus A2 minus B2 divided by 2. So this is nothing but a true difference in case of reciprocal leveling. So this is all about the methods of leveling, indirect leveling and direct leveling. Next there are some few important terms. In that, first one is station. So station is the point where staff is held, point where staff is held. So this is the station point. Then next, second is height of instrument. Height of instrument. So height of instrument is plane of sight with respect to assumed datum. Plane of sight with respect to assumed datum. Plane of sight with respect to assumed datum. Then third one is backside. Third one is backside. Okay, so here backside is taken on a staff held at the points of known elevation. Backside is a site which is taken on staff, and that held on unknown elevation, held on not unknown, held on known elevation. And this backside is the first reading. Backside is the first reading, and backside is also known as plus side. Backside is also known as plus side. Here the height of instrument is calculated with the help of backside. Height of instrument is nothing but a benchmark plus backside. Benchmark plus backside. Then next is fourth is free foresight. Next is foresight. So here foresight is a site taken on a staff held at unknown elevation. Here known elevation, and here foresight is taken on unknown elevation. Unknown elevation. Here RL is equals to, here reduced level is equals to height of instrument minus foresight. Height of instrument minus foresight, and this is also known as minus sight. Also known as minus sight. Okay, here this foresight is last reading. Foresight is last reading. Okay, this is about the backside and foresight. The next term is, fifth term is intermediate sight. Intermediate sight. So intermediate sight are the readings which are in between the backside and foresight. Okay, reading between the backside and foresight are nothing but an intermediate sight. Then next one is change point. Okay, change point is that point in which the same reading, or the point after which the instrument changes its place, is nothing but a change point. Here backside and foresight are taken on the same point. Okay, here backside is taken on that point which is foresight for the before point or the previous point. So this is nothing but a change point. Here we change the instrument station or instrument. Here we change the location of instrument. Okay, this is nothing but a change point. The next term is, the next are the types of levels. In that, first one is tilting level. So tilting level, in case of tilting level, the line of collimation of telescope is parallel to axis of bubble tube. Line of collimation line of collimation of telescope is parallel to axis of bubble tube. Axis of bubble tube. So this is about the tilting level. In case of tilting level, the leveling is done quickly. So here quick leveling is done. Quick leveling is done. Then next is line of sight can be treated slightly without tilting the vertical axis. Here the line of sight and vertical axis are not perpendicular. Line of sight and vertical axis are not perpendicular. Then next is Y level. In case of Y level, the adjustments can be done rapidly. Here, the adjustment in case of this level is done rapidly, but the adjustments are for shorter span. Okay, the adjustment span is very shorter span of adjustment. Then next is reversible level. So reversible level is the combination of dumpy level and Y level. Combination of dumpy level and Y level is nothing but a reversible level. Then next is dumpy level. So here dumpy level has a 4 components. First one is telescope. So telescope is used for line of sight, to draw the line of sight. Then next is level tube. This is used for the line of sight is horizontal or not. This is used to check the line of sight is horizontal or not. Then third one is leveling head. So this leveling head is used to make the center. Okay, to make the center of that instrument. So this bubble runs to make the center line of the level. Then next is tripod. Tripod is used to support the instrument. Okay, then advantages of this dumpy level are, here this dumpy level is with a movable parts. Then next, the adjustments are very less, fewer adjustments, and these adjustments are last long. So longer life of adjustment. Okay, then next are the adjustments, which are temporary adjustments and permanent adjustment. In that, first we see the temporary adjustments. So temporary adjustments in case of dumpy level are, first one is setting up the level. Then second is leveling up, setting up the level. Next is leveling up. Third is elimination of parallax. Then fourth is focusing the eyepiece. Fourth is focusing. In that, focusing the eyepiece for crosshairs and focusing the objective end for the image of that object. Okay, so these are the temporary adjustment. Then permanent adjustments for this dumpy level are permanent adjustment. So in the permanent adjustment, first one is vertical axis level is perpendicular to axis of bubble tube. Vertical axis level is perpendicular to axis of bubble tube. Then next is line of collimation is perpendicular to vertical axis. Then axis of bubble tube is parallel to line of collimation. Next is axis of telescope coincide the line of collimation. Then last is horizontal cross here is perpendicular to vertical axis. So these are the permanent adjustments for the dumpy level. The next point is, then next And last point of this video is curvature and refraction error. So in that, first equation is related to curvature correction. Curvature correction. So the formula to find out the curvature correction is CC is nothing but a curvature correction. Formula is d square divided by 2r, which is always negative, and this CC is nothing but 0.07849 d square, which is always negative. Okay, so this is about the curvature correction. Here the d square, put this d is in meter. Okay, then next is put this d is in kilometers. Okay, not in meter, kilometer. The next formula is about the curvature of refraction, curvature of refraction, curvature of refraction. Cr is equals to d square divided by 2r into 1 by 7. D square divided by 2r into 1 by 7. So Cr is equals to 0.01121 d square. Cr is equals to 0.01121 d square. This d is put in kilometers. Then next, third is combined correction. Combined correction. So combined correction is CC plus CR. CC plus CR. So here CR is always positive. So here CC value is minus d square divided by 2r, and CC value is minus d square divided by 2r, and CR value is d square divided by 2r into 1 by 7. So this value is minus 6 by 7 d square divided by 2r, and simplification value for this c is equals to 0.06728 d square, 0.06728 d square. Okay, so this is all about the leveling, and leveling is very important topic from the surveying. So this 20 minutes cover your leveling part completely. And okay, so this is the leveling, and thank you for watching the video.